Welcome everyone to our video on using solubility rules for ionic compounds. In this video, we are going to define solubility. We're going to learn how to use the solubility rules to determine the solubility of ionic compounds. And we'll look at an example of how we do that. The solubility of a substance refers to the amount of a solute which can be dissolved in a given amount of solvent. Note that this definition depends on two quantities, the amount of both the solute and the solvent. And when you think about it, there's obvious reasons for that. If you take a small amount of a solute and you try to dissolve it in a small amount of water, it may not dissolve. If you take that same amount of solute and drop it in Lake Huron, it's probably going to dissolve and disappear. The amount of solute which can be dissolved in a solvent depends on how much solvent you've got to dissolve it in. So we have to look at both quantities because we're talking about an impure substance. The solubility of compounds can be quantified with very precise numbers. For right now, we are going to look at solubility qualitatively by just classifying ionic compounds as being very soluble or having high solubility or having low solubility. The other term that's used is being slightly soluble. We're going to be talking about solubility in the context of chemical reactions often. If an ionic compound is produced in a chemical reaction and that ionic compound has low solubility, that is when we get a precipitate or a solid formed in a chemical reaction. If an ionic compound with high solubility is produced, the ions will remain in solution. Remember the difference between an ionic compound in its pure state as a solid and an ionic compound that is aqueous from our previous introductory video on solubility. When an ionic compound is dissolved in water, it's really not the compound itself that's together. The ions are totally separated from each other. They just exist in the same ratio. Here's a table of solubility rules, and you have the same one in your handout. Before getting into reading this table, make a few notes just about solubility and concentrations. The solubility of an ionic compound depends on the temperature it's at. So these are all referenced to room temperature, which is 25 degrees Celsius. We group compounds on whether they are very soluble or slightly soluble. So this group of ions at the top all have high solubility for most of the compounds that they form. Some of these compounds, such as nitrates, ammonium compounds, sodium, potassium, have no exceptions. Every ionic compound that's formed with one of those ions, regardless of what the anion is, or the cation in the case of nitrate, has high solubility. Acetate, sulfate, and the halides are typically highly soluble, but there are some exceptions here. So the exceptions are listed here. So ions that are formed between calcium 2+ and sulfate have low solubility. The same setup is here with the ions that have low solubility. Carbonates, phosphates, sulfites, and hydroxides mostly are slightly soluble, but there are some exceptions as well. And you can see those exceptions are typically group 1 ions in ammonium and a few other group 2 ions as well. Let's look at an example now and put this into practice. In this example, we will look at using the solubility rules in the context of a chemical reaction, which isn't the only way we can use them, but it's a common way we'll look at them in grade 11 chemistry. Here we have a double displacement reaction between potassium chloride and silver nitrate, with the products being potassium nitrate and silver chloride. Let's pull up the solubility rules and determine the states of these two products. My first product is KNO3, which is potassium nitrate. I'll start off by just going down this middle column and find one of those two ions. And first off, we see the nitrate ion. The nitrate is grouped in the very soluble compounds. And this table is nice because it shows you that very soluble compounds will remain aqueous, AQ, and there are no exceptions. So potassium nitrate will remain in solution, be aqueous. Silver chloride is our other product. So we'll move down again, and there is chloride. And the chlorides and halides are also very soluble, but there are some exceptions. And we see over here, Ag plus silver is one of the exceptions. So that means silver chloride will be a solid when it's formed in solution. So here's our products. KNO3 aqueous, and AgCl solid. So we predict if we mix these two solutions together, we'd see something come out of solution as a precipitate, and that substance would be silver chloride. So you can see what we can do here, which we haven't been able to do previously, is if we see a solid form in an aqueous ionic reaction, we can use the solubility rules to determine which of the products the precipitate is.